Hello everyone, my name is Nikhil sir of Support Classes Happirosti Hudi Road Sholapur. We have started 9th chapter of class 9 NCERT, that is Force and Laws of Motion. In that we have studied some part of this chapter. Now we will move towards on next page. If you have not seen my previous videos, please go through my previous videos. I have given you link of those videos in my description box. You please check my description box and go through previous videos. Now today we will start the next point in this chapter, that is 9.2, first law of motion. By observing the motion of object on an inclined plane, Galileo deduced that objects move with a constant speed when no force acts on them. After observing the motion of object on an inclined plane, see here, one inclined plane has shown you in this figure. Then Galileo deduced that objects move with a constant speed when no force acts on them. He observed that when a marble rolls down an inclined plane, its velocity increases. See here, he observed that when a marble rolls downside and inclined plane, its velocity increases. Now velocity, I have told you, velocity means magnitude and direction. That is figure number 9.5a. In the next chapter, you will learn that the marble falls under the unbalanced force of gravity as it rolls down and attains a definite velocity by the time it reaches the bottom. In the next chapter, we will learn the marble falls under the unbalanced force of gravity as it rolls down and attains a definite velocity by the time it reaches at the bottom. Its velocity decreases when it climbs up as shown in figure 9.5b. What happens when that marble goes upside? That time its velocity decreases. See here in this figure. Shows a marble resting on an ideal frictionless plane inclined on both sides. And 9.5c here, 9.5c shows that a marble shows resting on an ideal frictionless plane. Frictionless, there is no friction here. Plane inclined on both sides. See here. First it moves to downside and again it moves to upside. Galileo argued that when the marble is released from left, it would roll down the slope and goes up on the opposite side of the same height from which it was released. Galileo argued that when the marble is released from left side, means from here, it rolls downside the slope and goes up on the opposite side to the same height. See, the height is same height from which it was released. If the inclination of the planes on both sides are equal, then the marble will climb the same distance that it covered while rolling down. Means if the inclinations of the planes on both sides are equal, what will be happen? Then the marble, see here, the height is same. Then the marble will climb the same distance that it covered while rolling down. Means now see, while rolling down, it covered this much distance. Then again he covered next distance, which are same as previous. If the angle of inclination of the right side plane were gradually decreased. Now see, this is the inclination angle. If it will decrease, means suppose we are decrease means suppose we take here, means here, when we take now see the angle is decrease. Before it this was, now only it was. Before this and now this is only this angle decrease. Then the marble would travel further distances till it reaches the original height. What will be happen? Till it reaches the original height. If the right side plane were ultimately made horizontal, the slope is reduced to 0. What will be happen? If the right hand side angle become 0, the marble would continue to travel forever, trying to reach the same height that it was released from. Means again it travel the same height from where it was released. The unbalanced forces on the marble in this case are 0. Means unbalanced force is 0. It thus suggests that an unbalanced means external force is required to change the motion of the marble. Means unbalanced force is required here to change the motion of the marble. Means unbalanced force is here required to change the motion of the marble, but no net force is needed to sustain the uniform motion of the marble. See here. But no net force is required or needed to sustain the uniform motion of the marble. In practical situations, it is difficult to achieve a 0 unbalanced force. But in practical, it is difficult to achieve 0 unbalanced force. This is because of the presence of the frictional force acting opposite to the direction of the motion. And this is because the presence of a frictional force acting opposite to the direction of motion. Thus, in practice, the marble stops after traveling some distance. But in practice, marble stops after traveling some distance. The effect of the frictional force may be minimized by using the smooth marble and the smooth plane and providing a lubricant on top of the planes. And the effect of a frictional force may be minimized by using smooth marble. Means you have to take smooth marble and also you have to take smooth plane and providing a lubricant on the top of the planes. Let's see what is there in the next slide. Newton further studied Galileo's ideas on force and motion and presented 3 fundamental laws that govern the motion of an object. Newton studied further ideas of Galileo's of force and motion and presented 3 fundamental laws. These 3 laws are known as Newton's law of motions, and these 3 laws are known as Newton's laws of motion. the first law of motion is stated here. This is the first law now. An object remains in a state of rest or of uniform motion in a straight line unless compelled to change that state by an applied force. The object remains in the state of rest or uniform motion in a straight line unless compelled to change that state by an applied force. This is the first law of motion. The object in a state of rest or uniform motion. See here, means the object is in a straight line up to unless compelled to change that state by an applied force. When we apply force, that time it changes. In other words, all objects resist a change in their state of motion. Means all objects resist change in the state of motion. In a qualitative way, the tendency of an undisturbed object to stay at rest or to keep moving with the same velocity is called inertia. Now, this is a definition of inertia is that in a qualitative way, the tendency of an undisturbed object to stay at rest or to keep moving with the same velocity is called inertia. That is why the first law of motion is also known as the law of inertia. Means Newton's first law is also known as law of inertia. Now here certain experiences that we come across while traveling in a motor car can be explained on the basis of the law of inertia. Certain experiences that we come across while traveling in a motor car can be explained on the basis of law of inertia. We need to remain at rest with respect to the seat until the driver applies a brake force to stop the motor car. Suppose you are traveling in a motor car and when the driver applies brake, what will be happen? We move forth. Applies force, that time means when the driver applies a brake from off to stop the motor car. With the application of brakes, the car slows down, but our body tends to continue in the same state of motion because of inertia. And why this will happen? Because here reason has given. With the application of brakes, the car slows down, but our body tends to continue in the same state of motion because of its inertia. A sudden application of brakes may thus cause injuries to us by impact or collision with the panels in front. And sudden application of brakes causes injuries to us by impact or collision with the panels in front. Now we will move towards on next page. Safety belts are worn to prevent such accident, and we are using safety belt in the car are worn to prevent such accident. Safety belts exert a force on our body to make the forward motion slower, and safety belt helps to us on our body to make the forward motion slower. An opposite experience is encountered when we are standing in a bus and the bus begins to move suddenly. And next situation is in this way. Suppose you are standing in the bus and that time the bus is at the rest in its motion, means there is no speed in the motion, it is in rest condition. Then what will be happen when the bus will start? Our bodies move backside. This is because the sudden start of the bus brings motion to the bus as well as to our feet in contact with the floor of the bus. But the rest of our body opposes this motion because of its inertia. I think every student had experienced this condition. When a motor car makes a sharp turn at a high speed, now a motor car want to take turns, but that motor car's now in high speed. We tend to get thrown at one side. This can again be explained on the basis of the law of inertia. I think you are seeing in the movies. In the movies, a motor car in a high speed, and when it want to take turn, that it get thrown to one side. We tend to continue in our straight line motion when an unbalanced force is applied by the engine to change the direction of motion of the motor car. We slip to one side of the seat due to the inertia of our body. This will be not experienced in car only, but we can experience this situation also in the bus. The fact that a body will remain at rest unless acted upon by an unbalanced force can be illustrated through the following activities, and this we can illustrate by the using of some activities. These activities we will see in our next video. I hope you understood it better. If any queries is there, please ask your queries, we will clarify it. And please subscribe my channel and show your thumbs, and please share this video to your friends, neighbors and relatives. I hope you will do. Thank you.